some of the most fascinating work involving new digital technologies is happening in the mobility space. Autonomous driving is, of course, the ultimate vision. But even as we get there, numerous interesting developments are happening. Many cars no longer need keys to drive. Numerous parts in the car are collecting and sending out information to keep drivers aware of the conditions of those parts and how efficiently the car is being driven. Infotainment systems are being transformed. There are cars that are better at parallel parking themselves than many humans. The new trends in mobility, the digital engineering required for these developments, and the business model changes that these are bringing us some of the subjects of our discussion today. So welcome to this Times Techies webinar. I'm Sujit John, and I have with me my colleague Shilpa Fatnis. The two of us will moderate the discussion, which we are having in association with Nagarro, the digital product engineering and technology company. We have three seasoned professionals on the panel with us today. We have with us Rishi Ranga. Rishi leads the automotive and future mobility practice at Nagarro. His experience spans across product strategy, management consulting, B2B marketing, and software engineering. Over the years, Rishi has partnered with several automotive industry leaders and new mobility entrants to help them achieve their digital product innovation and large-scale transformation goals. He currently lives in Munich. Prior to Nagarro, Rishi was with TCS for almost 10 years. Welcome, Rishi.
Thanks, Vijay. Thanks for having me.
We have with us Anurag Sahay. Anurag is MD at Nagarro and a global business unit head leading the AI and data science practice. He started his career in 1993 and with IBM in Austin, where he worked on performance modeling. He joined Epsilon Network in Palo Alto in 1995. Later, he moved to Nokia as part of the Epsilon acquisition. In 2004, Anurag moved to Microsoft as a part of the Microsoft Mobile Protocol team. In 2008, he moved back to India, taught in an engineering college, and became a part of a disease diagnosis startup. Anurag joined Nagarro about 6 years ago. Welcome, Anurag.
Thank you, Shilpa.
We have with us Sven Sommerfield. Sven is the managing director at ATCS, a technology consulting firm providing services in the area of enterprise IT, digital transformation, data analytics, and marketing insights. ATCS was acquired by Nagarro last year. Sven joined ATCS in 2013, prior to which he worked with Capgemini. He now works with customers to drive digital transformation, how to use digital solutions to increase efficiencies, reduce cost, increase revenue without having to stretch their budgets. Welcome, Sven.
Thank you, Shilpa. Thank you for having me, and thanks to our welcome to our audience. Looking forward to the conversation now.
Those of you viewing this can send in questions to the Facebook comment box. Sujit and I will put them to Rishi, Anurag, and Sven. Let's start with you, Rishi. What's the big change that is happening in the world of mobility?
Thanks, Shilpa, and yeah, a very warm welcome to our audiences as well. I think Sujit very rightly, articulated the big changes that are happening in the world of mobility. I think there are various ways to look at this entire change, but if we had to sort of create a mental model to see what are the big developments that are happening in the industry today, I'd say that there are three. Number one, I think the consumer is changing. The new age mobility consumer today, expects machines to be smarter and devices to be more intuitive. They expect services to be simplified and personalized to their preferences. And I think this basic consumer expectation is impacting and influencing every aspect of our lives, every business, and mobility being no exception to that. And I think what's happening consequently is that businesses are pivoting their offerings, their positioning, their value proposition, their ways of working, and their culture to cater to the needs of this new consumer. The second big change is that the product that if we talk of vehicular mobility, the product itself, the vehicle, is advancing significantly. It used to be an electromechanical device, and now it's turning into a full-fledged experience zone. We all are hearing about the whole EV revolution as well. And I think only last week we had news that one of the German car brands actually ran, one of the latest cars, which ran for almost 1,000 kilometers in a single charge, and with 140 kilometers of charging still left on it. So EVs are big, and even the form factor of vehicles is changing. You have the burgeoning space of lightweight electric vehicles, kick scooters that are very useful for short distance travel and for various use cases. And that in fact takes me to the third big change, which is the ecosystem of mobility that's coming up, where the whole outlook towards personal mobility is shifting from ownership to usership. So yeah, I think these are the three big changes that I see are driving the disruption, if you will, in the industry today.
Which is the scooter you mentioned, Rishi?
You have these e-scooters or kick scooters, companies like Lime and Pierre and Dot and all of those. So I use them quite a lot in Germany. I think they're pretty useful for short distance travel. Yeah.
Okay. And the shift to usership, is that a big trend?
I think absolutely. I think it's a big trend. It's going to get bigger. It's only a question of how much and how soon. I think we are seeing that because of the world population is going to be 10 billion by 2050, and 70% of the people are going to be living in cities. And this rising urbanization, along with this push for sustainability, is really driving this sharing economy, right? And because in the current format, the whole mobility operating system would not be sustainable. So you need a 2.0 version of it, which is more connected, more cooperative, and where the energy management, the pollutions, the carbon emissions, all of those aspects are also taken care of. And I see that even the incumbent companies, large automotive OEMs, they're also transitioning from being automobile manufacturers to becoming mobility solutions providers. So that's a very big change in across the world. I mean, we have and a lot of our customers also, we've been working with them to help them establish these new lines of businesses from really from 0 to 1 and then 1 to 100. So I definitely would bet heavily that this change is going to be big.
Okay. We'll come to more of that a little later. Before that, Anurag, tell us, how has technology evolved, and what are some key technology milestones that has got us to this stage of digitalization in the automotive industry?
Absolutely, Sujit. So I'm a big believer of evolution, and it's like a slow change that is constantly happening, and then one day we wake up to something really dramatic has happened, kind of a thing. And pretty much this whole century is a story of, if you just take one, the car or the automotive, and then you just journey through the whole 100 years that it has evolved, you can see how our value systems, technology, all of these have come together in small evolutionary steps to bring this about. We sort of start from the place, there was a time when a vehicle was meant to be a good replacement for a horse-drawn carriage, right? That was the place where we started from. And then, so it was a mechanical device. It was meant to be able to generate power and generate enough power that, several horses, it could outrun several horses quickly. And they did a pretty good job at it, right? So this was the mechanical era of car engines and so forth. The next interesting milestone happened when Bosch explored the idea of introducing electronics into the engine, and then they came up with this. There was this one particular physicist, Dr. Kaap, I think, I can't remember his name fully, but this is Bosch for sure. And their engine innovation system called Jetronic, this happened in the 60s. There were these bunch of engineers who used to think that if there was a way for us to electronically inject the fuel and ignite the fuel instead of a mechanical system, and if we could read the temperature and airflow precisely, they could build something like that. And they did this. And interesting, there's a very interesting story around it, right? They actually bought a Mercedes-Benz 300 to try out this as a testing thing. And they would replace that whole carburetor engine and put their own assembly in there and try all their tests. And once they were done and they had to take the car back to the service, they would actually replace the carburetor engine back, take it to service, and then bring it back so that Mercedes-Benz does not, figure this out, like what kind of thing is being done, right? Bosch was the pioneer in this. They were able to convince Volkswagen to be able to take this electronic assembly thing. And that's the first electronic innovation in the engine system that came about. And interestingly and strangely, in the next 5 years, and this is how the world converges in interesting ways, right? LA and several other cities in US, they were getting bogged down with smog because of the carburetor ignition system. And they passed a regulation saying, we got to stop these carburetor systems. And lo and behold, just like 5 years before that, this engine had already been prepared, right? And Volkswagen was a success, and they could convince other companies to do that. And then that kind of thing happened. Then for the next few years, GM made this very interesting innovation where they sort of figured out, like, well, let's take this kind of innovation of an electronic injection system and make it distributionless, like have multiple coils, and it could fire at multiple coils at the same time. For them to be able to do something like that, they had to actually get sensor readings from multiple locations, airflow from multiple locations. And that was the beginning of the sensor instrumentation. So they instrumented the engine with sensors, read all that information, and then injected all that fuel. And that was an exponentially better system. And that was the second, third, innovation. From there on, everything was just electronic, it was just waiting to happen. So the onboard dashboard system, which I also call sometimes the idiot lights, like you see this pink light comes on, this yellow light, it confuses the hell out of me, right? I can't figure that out. But what I think it's meant to do is that when you see that light, you go to a mechanic and they can fix that kind of thing, right? So computerization software started making an entry because there were just so many sensors that had been already, that the engine had already been instrumented with, that you could not have done anything without that. And that was the beginning of software already part of the engine assembly, sensors already part of the engine assembly. And all of these things happened, and they happened gradually over the next 20, 30, 40 years. Obviously, during this time, it was not just the engine, but the headlights that were getting changed. And like Rishi talked about, several other aspects of the body, carbon fibers, and many other things started coming about. Safety became a big deal. And people started focusing a lot on safety. Performance was already something that people were thinking about. Automation began to become a very important thing. There's this, very passionate car designers feel that human drivers are really not the best people to drive their cars because they just don't understand the engine and the machinery, and there's this snobbery around it. But there is a good reason to understand, sort of think about that as well, right? When we are, for example, doing a very fast turn, our experience tells us at what rate should we turn, right? But there's a whole bunch of electronic support that is actually playing out when we are doing that. And when one is doing that, it's not just simply intuition, but a lot of electronic stabilization that is going on that the engineers have already built in. So automation, if you see that, right, some kind of automation is already built in by the time, we hit the early 2000s or the middle 2000s, so to speak, right? So computers are here, sensors are already there, partial automation is already there. And now we're sitting in 2020 thinking, or 2022 now, right? Thinking about what could be the next thing. And so we are sort of at the dawn of when obviously AI and these technologies are now making, they're ready. We are also ready. The car is also ready. At the service level, things are also ready. So that kind of an evolution has taken place. It's a very interesting story. I found it very fascinating when I was researching this.
So these, so right now, what would be the big things that happened? Cloud and all have been very important to the evolution of this?
So the cloud's now going to play a very important role. The big thing is driving is going to become fully automated in my mind. That's the idea. The idea is to really take driving to the level where it becomes a completely automated experience, a beautiful experience, and different companies are taking different journeys to get there. Google's Waymo, for example, is taking the path of, they use a lot of LiDAR data, and then using that kind of instrumentation, build fully automated cars, whereas Tesla is taking a semi-autonomous road to trying and solving this problem. But I think the big steps are AI. In my mind, the big next step is AI, which is going to take us to automation. And AI is going to be supported by things like cloud engineering and data support and so forth. But I think the big story is automated self-driving cars, of course, and energy, of course, right? So automation, energy, these are the
energy, you mean?
EVs playing out, right? So in my mind, those are the three things, right? The car as a robot, as a agent which is interacting with the environment as one big element. How efficiently is that going to be designed and played out? The second is AI-driven interaction, which, where the AI is in control, it's driving and providing fully automated outcomes. And of course, the infrastructure that is going to play out in the car to make all this happen.
Okay.
Of course, the business models that Rishi is talking about will all get enabled from something like that.
Okay. We will come to more of that. Shilpa? Shilpa, you're muted. Shilpa, we can't hear you. Can't hear Shilpa, no?
Yeah, we can't hear her.
Shilpa, we can't hear you. No, we can't hear you. Just check on that, Shilpa. No. Yeah.
Could be a microphone problem, because last
Hello.
time she was.
Now we can. Yeah, there you go. Yeah. No, again, you can't.
Okay.
No, Shilpa. No, there's something in between. We could hear you briefly and then it went off again. I think this was happening earlier as well. Okay, let me ask Sven this question. Sven, how should organizations change to be able to deliver on, the kind of things Rishi and Anurag were talking about? How do we get there?
Yeah, so I think Anurag, Rishi, and you touched on a lot of things that are happening right now, right? In the end, if we look at the automotive industry or the mobility industry, the change that has been brought to that industry has been tremendous in the last 5-6 years, right? Of course, everyone thinks about Tesla driving that change. And I think that's also a good example to look at it. But Tesla is not only this, right? It's just one example of this. But if you just look at how the situation is now in the mobility space, right? Earlier, you knew your competition also, right? You knew who are the big automakers. The goal was to produce a car, right? And the car has to be the most luxurious or the best for the person you want to buy the car. But in the end, it was all about the car, right? The car was in the center of the thinking. The car was in the center of what you're going to produce. Now your competition has changed, right? Rishi was pointing out these e-scooters. Now you suddenly, in the mobility space, your competition is not a train or maybe a bus. It's other things too, which are easy to assemble, easy to bring in, easy to roll out, right? Or easier to roll out. Nothing is easy, but easier to roll out. Secondly, with this whole EV movement and everything, you now have companies like Google into the space. You have and an Apple who's thinking about it. You have a Tesla emerging out of this, because the car itself, the engine itself, is easier to assemble, easier to produce, and you can get it done with less resources. Still, you need that knowledge on how to assemble a car. But in the end, again, right now we're talking about a car. It's not about a car. It's about how to get from A to B. And also Rishi was touching on that sense of ownership versus sense of usership on how the consumer is changing. And I think this is the key point where organizations need to change or will change in the future. Is in the past, the focus was on the car or the product itself. Now the focus will be on the user. What does your customer actually need? And how do you achieve that? And how can you provide value to that customer every single day? And how can you react to feedback of that customer? How can you make sure that your customer is heard and that they get the value they are wishing for? And I think this is what needs to be integrated into an organization now. So in software development, on a high level, and there are different discussions around this, but high level, we call this agile. Yeah, you have short cycles, value creation is in the middle of everything. The customer is in the middle of everything. You need to provide a valuable product to your customer every time you ship something out. And you don't want to ship something out once a year. You want to ship something out every week, every other week, so that there's a continuous value creation. And I think this idea of agile, that's what I put it, will be transforming into these companies. And there's a lot of change in that, right? I mean, the word change came up a lot, and the change management behind this is tremendous, because you are having now new competitors on the market, which are starting from a green field or are coming out of this mindset, right? A Google, they live agile every day from the start of their founding period. You have a Tesla, which comes kind of out of a green field. They can start everything. They can set up the organization differently. And also they had nothing to lose, right? They only could win, so they could disrupt in different ways of thinking. And then you have the incumbents who have a historically grown organization with historical hierarchies and everything. And now to change this is a tremendous effort, and needs time to adjust. Nevertheless, having seen this now over the last 4 or 5 years, the rate of adoption on the incumbents, on the traditional OEMs, I don't like the term that much, but the OEMs which have been around for longer, is tremendous, and it's impressive to me to see that. But I think this is how organizations have changed and will change in the future even more. And I think it will be really transformation to agile, focusing on the customer, and integration of a product mindset. What I mean by that is, think in the sense of your customer, right? You want to produce value, you want to produce a product. And this in 2 ways. One way is, let's produce something, try it out, get feedback, improve it, give it to the customer, get feedback, improve it. And also, if it doesn't fit, you have to back out of this, right? If it doesn't fit, you have to back out of it and concentrate on something else, because your customer won't wait. If you don't produce it, somebody else brings it to the customer, and they will have the first mover advantage. But in a nutshell, I think this is what we will see in a more way that these OEMs or the whole mobility sector will move heavily into this agility. And then also we will see, from an organization point of view, of course, business is a very important part, understanding the business, but we will also see a transition to a more technical company, because in the middle of everything, and that's what Anurag was pointing to, is it's a technology part. You need to understand data, you need to understand technology, you need to understand how this flows, and you want to have this in your company. You don't want to fully outsource this. You will need partners, but in the end, these are the 2 things I see. One is deeper shift into agility. Secondly, more technical workforce in the mobility sector.
And partnerships. Okay. Sven, you are in Stuttgart, one of the world's big automotive hubs. Some of the traditional companies are all sitting out of there. I assume Mercedes-Benz, BMW, many of the big German names. You've seen them becoming a lot more agile now. Is that very visible? And the technical workforces, have they changed a lot?
Yeah, so BMW is not in Stuttgart, it's in Munich, but it's very close.
Okay.
It's okay to put it into Stuttgart. I'm fine with it. I'm not sure Munich is fine with that. No, but Stuttgart is Mercedes-Benz and Porsche.
Mercedes and then Porsche, okay.
The big ones. Yeah, no, so I've seen that. So there has been a tremendous effort on different OEMs I have worked with to have all these agile coaches coming in to help transform the organization into a more agile way. Offices have changed from classical, and this is just minor things, but it all piles up, right? From typical 2 to 3 people offices to open space offices, which now is a perfect fit, right? Nobody could see COVID coming, but now having this more open space and an open seat concept, of course, helps too. But all these things are helping to drive that agile idea, right? You're not in your room, you're in one team, everyone is working together. You emphasize to exchange ideas, and you emphasize to bring innovation forward, which helps the customer. And this is, I've seen a big change over the last years in that space specifically.
Okay.
If I could just weigh in on that, I think
Sure.
what's happening is that there's a lot of executive sponsorship now to agility. Instead of it being looked at something that needs to be done in a silo, I think these large global organizations are understanding and at the highest level that there has to be a concerted effort towards becoming more agile, towards becoming a product organization, as Sven mentioned, and really creating that product innovation pipeline, right? And then with a very agile mindset and approach, following that pipeline and creating incremental value, for their customers. So that's definitely visible. The cultural change is visible. The technology adoption that's needed for becoming more agile is equally, visible. So, setting up the right technology infrastructure that equips the organization at all fronts to be agile, to be more responsive. Even that's taking shape, and different customers, and we work with a lot of them, I think, are at different levels of maturity, but I think there is a clear focus across the spectrum on the topic of Sven that Sven mentioned, agility and innovation. Yeah.
Okay. Rishi, but I mean, of course, Tesla is there, but then Google, Apple, and all we've been hearing. Where are they? I mean, is there competition emerging from there? Yes.
I think so. I think definitely there is, there is competition, and then there is also cooperation. You sort of cooperate on standardization, and then you compete on innovation, right? So they are very powerful companies, and I think I completely agree with Sven. They have been agile right from get-go. Anurag would probably agree that they are Google is incredible when it comes to AI and data technology. So they're really miles ahead and really have all the wherewithal needed to spearhead this AI dominated transformation, especially on the vehicle side, of the automobile side. Google also has its own cloud, and that also helps create this whole ecosystem, a more powerful ecosystem where they could create their own unique positioning and in the mobility industry. So yeah, definitely.
Okay. And business model changes wise, what is the thing that you see, Rishi? How is data playing a role in that?
See, I think what's as I said, this whole there's this whole ecosystem of mobility that's getting created, and if I were to define this ecosystem, there are several entities. You've got automotive OEMs, you've got technology companies, you've got municipal organizations, governments, telcos, startups. All of them are coming together and in a connected and cooperative way are trying to offer mobility solutions and services tailored to the consumer's needs. And inherently in this definition itself, there is innovation lying, because this is a new concept altogether. And then introducing a new mobility use case or solution is one thing, but to really tailor it to a city's concept, construct is a different thing. You need to make sure that assets, all your mobility assets are optimally utilized. Your mobility systems are, responsive enough, they're efficient enough, costs are managed nicely, and there's a lot of innovation that can happen there. And there are a lot of value-added, players that are coming in and doing their bit in this space. Data playing a role, of course. I think all of the entities that I mentioned, they are massive producers as well as consumers of data. And this data has a lot of intrinsic value, which can be monetized, right? I mean, there are reports that suggest that up to 2030, vehicle data monetization itself will be a $400 billion industry. So there's a lot of potential that this data holds. But I believe beyond just this monetization part, I'm betting even heavier on the fact that data is the oxygen that this entire mobility operating system needs in order to be sustainable, efficient, and responsive to the consumer's needs.
Okay. Shilpa, is your system okay now?
You hear me now?
Yeah.
Okay. Anurag, coming to you, what do you see are the key investments in technologies that you're doing or the clients are doing in the areas of AI and mobility?
So several, and I'll just try and pick up on some of those things that Sujit was asking asking Rishi a little. But let me backtrack so that I can put it all in context. So from a technology perspective, right? I mean, we always ask ourselves the question, what are the key drivers for technology adoption? Like, why would somebody go to new technology? What is driving that, right? So from our perspective, when we look at it from a technology perspective, there are three important drivers. One is safety, human safety. Nobody would disagree on that. Typically, every 23 seconds, a person dies because of road crashes in this world, right? So every 23 seconds, there is a fatality. This is too much. 23 seconds is just too small a time. I mean, I finish a sentence and somebody is dead, that kind of time, right? So this is obviously a problem. The second is the second important driver towards more technology adoption is improving human experience. I mean, while safety is important, improving experience is one key driver for new technology adoption. If one is not doing that, and experience is fairly important. There's been a whole bunch of studies around how people live in their cars, how people behave in their cars. We almost treat it like our bathrooms. We sing there, we have all kinds of emotions. I don't know if you have I kind of do a lot of, it's sort of like my personal space, right? And I use it like my personal space. And we're talking of passenger vehicles, but think about so many other types of vehicles, right? They all have different context, but experience is fairly important. The third is, can we think of new business models to monetize and create new value-added services? These are the three key drivers in my mind, which are playing out in different ways to let organizations adopt different kinds of technology. Now, we can take a step back and we can try and see, what is this ecosystem look? How does this ecosystem look from a technology perspective? So first of all, there is a robot on wheels, like this is the car, right? This whole, if you've seen the movie Transformer, right? I mean, the thing becomes a robot, humanoid, robotoid, whatever you want to call them, right? So it is actually that, right? It's a machine which is on wheels, doesn't walk, but practically for every other purpose, it's a robot, right? It's an automaton. And then to make it further and more complicated, this automaton has to interact with a human being who's sitting inside it, right? And so there is a whole interface, a human automaton interface, which has to be thought of at some level. It makes things more complex. I mean, it's way more complex than just having an automaton do a certain task, right? The human being is planning the drive, they are planning their goals, they're planning the way to get there, and the automaton is cooperating with the human being in some certain ways to achieve that outcome. And this cooperation has to be spectacular for that experience to be precise, right? Then if we look at this human machine agent, they live in a complex system of highways, traffic lights, roadway systems, and they have to journey with other humanoids also, other agents also of similar type in this ecosystem. So there has to be some kind of a communication that has to be built in at some level, at that level. So that's like the second level of complexity. Add to that the whole energy paradigm. These are agents which consume energy, and they, emit all kinds of outcomes. How does that interaction with nature, with our environment look like in this whole world that we are living in? So it's a multi-layered problem, right? And these are the key drivers. I mean, safety, human experience, and new value-added services. So the thing is that, pretty much everybody has sort of realized this complexity. We are coming to face and look at this as a very complex system. We understand that the kinds of answers we have to provide have to involve pretty dramatic technologies. AI is one of them, but there are several others. And I just don't want to, sort of make the other ones not important. There are quite a few technologies which I'm not able to name because those are areas I'm not an expert in. But I can clearly see AI is playing a very significant role in making a lot of this happen. So, for example, actually, one of the outcomes from a Tesla autopilot experience, or what they're doing in Tesla autopilot development program, is this humanoid robot, a Tesla bot, which even Elon Musk feels is going to be a bigger discovery than the self-driving car experience, because in trying to get there, they have had to sort of engineer this bot which would interact, which would make the interaction between the human and the automaton so wonderful and so comfortable that it would provide a whole new dimension in itself as an activity. So a lot of moving pieces here, right? And lots of different technology investments have to be made going forward. So one key area is, of course, AI. And there is one specific area in AI called reinforcement learning, which is one of the powerful ways to think about how AI sort of can change an environment like that. So the way it's worked, the whole reinforcement paradigm works is that this whole human automaton agent is interacting with the environment. It's perceiving the environment. And how does it perceive the environment? So far, the human being was using their eyes to perceive the environment, but now the human being can sit back, and there are 8 cameras. For example, in the Tesla setup, there are 8 cameras. If you talk about the Google setup, there is a LiDAR setup, a radar setup. They don't use so much of visual cameras, but they use these in-depth 3D point cloud images to make it more precise for their driving experience. But generally speaking, the interaction with the environment is happening through these cameras, these sensors. Now, all of that information is coming in, and then through actuators, action is happening on that environment. So the car moves, exteriors, appropriately navigates, and so forth. So there are 4 or 5 important things that are happening here. One is there's something called localization and mapping. So a lot of companies are investing in this technology called localization and mapping, which means that can the car answer this question, where is it in the scheme of things? And that means not just from a lat long perspective, but in terms of on a highway, which lane is it on? How fast is it going? And so forth, right? So it should be able to localize itself precisely on a map of a certain, on a certain space. The second key area is scene understanding. Scene understanding is basically that, does the car understand in a 360-degree format what's happening around it? So can it map every other car? Can it map all pedestrians? Can it map their movements? Can it project what and where will they be 5 seconds later? So it has to build this sort of a vector space of how things look like. So not only does it have to locate itself, it has to locate the entire scene. Then on top of that, it has to plan a journey from point A to point B. So if I need to go from somewhere to, from my Denver hotel to the Denver airport, I need to, not only navigate through highways, but also through intersections, through traffic lights, and so forth. So can I plan a journey, and not only just plan it once, but dynamically change it in the face of changing conditions? So that's like a whole area of technology itself. And then the fourth one is, around, does the car understand the internal state of how it looks like with the people who are sitting in the car is everybody okay? Are they distracted? Is there any health crisis happening? Is the air conditioner fine? Is the music playing okay? And there is a whole state within the car that it's tracking, right? So these are like the 4 areas that there's a lot of different investments going on in different manners. Like I said, AI is the key technology that is orchestrating all of that. And when you think about that, right, there are like some really complex engineering problems that are going on here. So one is data set, like Rishi mentioned, right? I mean, what and how data is going to enable something like that, right? Now, the first problem is if you're going to build AI solutions, you better have a lot of data set which you can use to train your models. There's something called learning that has to happen, and data is the key idea to use that to be able to train these models. Now, unless you have enough cars out there, how would you even get that data, right? So companies, if I'm a company and I tomorrow decide to build like a self-driving car, how am I going to build that? Because where am I going to get this data from? So companies which have had a head start, like Tesla and Google, are the kinds of companies which own a lot of that. Tesla, for example, has 1.5 petabytes of training data available under several different conditions, right? And even that is not enough. This means nighttime driving, low light driving, driving in rain, driving in snow, you name it. There are just so many different scenarios. So today, Tesla manufactures about 500,000, 600,000 cars every year. And for every car that goes out there, which switches on to autopilot, it becomes a source of data collection. And they have created this huge amount of data, and they are like way ahead from a whole bunch of competition when it comes to data sets. And this is actually creating that critical mass to even move faster going forward. I'm actually pretty high on Tesla in terms of what they are doing. I think their approach is pretty fantastic. They're taking the approach of what is called semi-autonomous vehicle, like use the car and the human being to build an experience and then use that as a basis to go to full autonomy. Google has taken a totally different approach. Google says, don't want that. We want driverless cars. So their cars, the Waymo company, right? Their cars don't have any drivers. It will be a fully self-driven car, like a fully autonomous car from day one. So it's a very different approach, and that's leading to a totally different set of consequences. Tesla is taking a totally different approach. A lot of industries now beginning to form a view about which is a better approach to go in what direction, so to speak, right? So that's like the first problem, data. The second is you have all that data. How are you going to use that if you don't label it properly? So you have to sit and label data, right? You need really extraordinary tools to be able to label data. It can't just be done by people sitting and doing very simple things. You require sophisticated tooling to be able to label all that data. So that's like the second engineering problem. The third is, okay, now you have data, you have labeled it, you have had human beings comment on that data, annotate on that data very expertly. How are you going to use to train that model? Because to train a model that can actually bring a self-driving experience like what it does in Tesla, it takes about 10,000 GPUs. A GPU is like a very strong CPU. You can think of that. 10,000 of them for 2 weeks to train a model. So you can imagine the kind of cost it takes to train a model. Now you require a whole bunch of engineers who can train one model on 10,000 machines. So the kind of distributed engineering that requires is mind-boggling, right? So that's like the third problem. Then you need something on the car, like there is a card onboard computer on the car, because the car computer can fail. What will happen if the car is driving and the computer crashes? What is going to happen, right? So you need redundant computers on the car running all these inference models, so to speak, right? So all of this is playing out at some level. So these are the kinds of technology places where a lot of investment is going on, especially when it comes to AI-oriented driving experiences. And we see a whole bunch of things being done in many, many different spaces.
Tesla systems have made mistakes. I believe there have been accidents and all that, isn't it?
6 fatalities. But so in terms of, there are two kinds of stats here, right? So if you have to really compare them, apples to apples and oranges to oranges, it will be like how many miles, how many accidents per mile, how many fatalities per mile. So when it comes to accidents, there are slightly more. I think it's about 1 in every 100,000 miles that there is a fatality in one in every 100,000 miles, there is a fatality when it comes to normal vehicles, and one in 250,000 miles, 250 million miles, sorry, one in every 100 million mile, there is a fatality in normal cars, and one in every 250 miles. So when it comes to fatalities, self-driving cars are way safer. Yeah. Already they are safer. But you know, there are other metrics to measure it. Like the one thing that Tesla does is that every time the car does not know how to deal with a situation, it says to the driver, take the control back, right? And so you can measure how many times it's doing that, and that kind of thing, right? So if you measure that, there are some scenarios that are playing out where the car very quickly hands off some of these things too. And you know, one important thing that they're doing nowadays is that they have these simulation platforms, right? You can't model all these edge cases. Like for example, let's say I want to model the scenario that I'm driving and a pedestrian, a big guy with a child is walking, and suddenly the child scoots. Now that's a scenario you will never actually get a data set for, right? Because hopefully it doesn't happen in the real world, but you still want to be prepared for something like this. So how do you do that? So you run simulations and you train your models on those simulation environments. So it's a pretty fantastic technological ecosystem that's getting developed. Yeah. I think it's fantastic. And in a few more years, we will see self-driving come of age, and the kind of technologies that it would have enabled is mind-boggling.
Oh, so fascinating. The other day I heard, even though the car alerted, I think the driver had just dozed off because he didn't have anything to do. He didn't even hear the car's alert. There are several questions on AI and all coming. But before that, Sven, I mean, you did talk about partnerships, but can you more elaborate? I mean, this requires a wide range of partnerships to bring all these technological changes, is it? Are companies also partnering with companies like Google and Apple and all that, or are they very independent guys?
No, I think so. This is, by the way, Anurag, I'm very, very excited about this self-driving experience, autonomous. This is also what I'm waiting for years to happen, because I'm very excited about this. Will open new possibilities we can't imagine right now. But Suchit, to answer your question, Rishi has also touched on this quickly. You have these concepts of co-opetition, right? You collaborate on the standards and you compete on the innovation. And I think that's also how it is here. In the end, also you have to imagine the ecosystem you're dealing with here is really, really big, right? Because we're talking about mobility, which means you have to look at all the vehicles. You have everything that's in that world, right? That could be a car, could be an e-scooter, could be a train, could be a bicycle, could be anything, right? You have all these players in your ecosystem, because in the end, the target is not to get you into a car. The target is to move you from A to B, right? That's what mobility means, and get there in the best way for you. So the ecosystem you are dealing with is enormous, right? Also, you need to have, anyway, partnerships in different ways, right? We talked about cloud. Typically, as a typical company, you don't build your own cloud and just run everything there. You will use existing infrastructure because it's faster, cheaper, secure, and all these kind of benefits you will get. Then you also need, we have not yet touched on smart cities and the impact of smart cities on future mobility, which is also a big play which take place, and the data will feed into what Anurag was describing. So you have a huge ecosystem to take care of, and like for one product, if you look at it, right, Tesla is doing a very deep integration. They try to do everything in-house, from the chip to the software to the car itself. But not everyone can do that and wants to do that. So partnerships are necessary in each space. And now specifically in the area we are at as ATCS and Nagarro, which is software development, API management, all these kind of things. But basically the software of the car, not the hardware. And this is also where you are looking for partners who are also in the same mindset, right? So you need partners who come in with an agile mindset, with a product-oriented mindset, to help you drive your business, to help you drive the business, to help you achieve what you want to do, is to become one of the major players in mobility. And there are several angles to it. Anurag was also touching on that, right? It's the 3 points, and one of these points is also value-added services. How can you do this? How can you come up with new ideas how to add services to that? And how can you also monetize that from a perspective of a company, right? Because in the end, you want to create value for your customers, but that in the end also creates value for you as a company. So you will need partners. You will need partners in that area, like Nagarro, who can come in with that agile mindset, with that product orientation, with the engineering DNA to help you help produce products to achieve the goal to be the main player in future mobility.
Yeah, you need partners to bring everybody together. Yeah, absolutely. There are lots of questions coming in. Obviously, this is a very interesting subject. Shilpa, multiple questions.
Yeah, multiple questions coming in. The first one is from so many questions.
Yeah, this
is I think from Rajesh Gajar. Would AI help in eliminating Ubers in future?
Huh?
Ubers in future.
Rishi, you want to? Will AI help in eliminating Ubers? And somebody who's frustrated with Uber, I think.
I think. Well, it's a great question, because I think what the question is trying to suggest is that ride hailing is probably not working in the most elegant ways right now as perhaps consumers would want. Maybe that's the connotation that I'm gathering from this question. But definitely, I think AI or data is going to make things better. That's the promise that data really brings to you, right? If you use data to take decisions, you obviously you get better. I think what's going to happen is that we'll be using more data to make these shared, mobility models more efficient and responsive, and and also make the entire mobility operating system of a city better. And what I mean by that is that today there is no way to gauge or no way to plan how much of ride hailing do you need in a city, and how much of public transportation like trains and buses do you need. And in developing economies and very populated cities like, let's say, New Delhi or Mumbai, that's very important, so that you can optimally utilize the city's infrastructure and make sure that it's not burdening one kind of mobility service, and probably not using the other one as efficiently as we could, or it's underutilizing that mobility asset. So definitely AI can make things better, but I'd really request Anurag to also comment on that.
It sounds like a political question. I have no idea what to answer. But frankly, I think Uber is experimenting a lot with self-driving cars as well. Yeah. So maybe AI can improve Uber experience for all of us. And Uber is a pretty interesting presence. They have an innovative model. There probably are some things that they need to sort out, but they're experimenting heavily with self-driving cars too. So it might improve the overall experience.
Okay. There's this question from Dharmesh Ranga, which Anurag, we were discussing just before our discussion started. You said you may want to talk about it. He's asking the same question. Would an enhanced AI interface be needed for Indian roads for self-driven cars?
Yes. Absolutely. So interestingly, the way a lot of companies, there are two ways to approach the driving problem. One is a driving problem like a chess game, or is a driving problem like a conversation? So here are things. A chess game is a very constrained system. There is a fixed set of rules. You can only move here, move there. You have to wait for your turn. But it's a very finite system with a constrained set of rules. It's actually very easy to write AI for a constrained set of things, because everything is well defined. So sometimes we think of driving like that. If you think of driving like that, and you think of like, a road with like lanes, and everybody's just driving on lanes, and everybody switches off lanes when the speeds are, and it's like very orderly, maybe like the Autobahns, when I don't know if that's like it's in the Autobahn, or maybe in US driving conditions, definitely not India. If you think of India, right, think of a roundabout in Delhi, like in the Connaught Circus, right? Like where there are no traffic lights and people are merging, and magically everybody manages to find the roads that they need to get to. And you get, it's like a game theory thing, right? You accelerate, and because you accelerate, the other deaccelerates. If you haven't accelerated fast enough, the other will accelerate. And so there is some conversation going on between two cars. It's non-verbal, it's completely cued, it's game theoretic. Interestingly, a lot of AI that is being planned is thought of as a conversation more. And so a lot of these models that are now being developed are trying to figure out that once we get connected cars, like if cars could actually talk to each other, you could do away with traffic lights. All the cars in a system can actually talk to each other to figure out how to optimally move in such a direction that we didn't need traffic lights. And so there are actually simulations like that, actually plans like that, and actually movements in that direction. My feeling is connected cars is a big factor there, that the moment 5G comes by and we have a good way to talk to every car, this is going to be a no problem, and we'll actually have a very nice conversation. It would almost be like a dance happening between cars.
So that's a distinct possibility, and not before too long.
No. There is a chance. There are people who are saying that, by 2040, 2045, there are going to be cities in US which are going to ban manual driving because it's going to be so unsafe. And these are like heads of AI people and companies which are calling this out, right? So my feeling is, yeah, we are talking at most decades, not definitely anything more.
Okay. Okay. Shilpa?
Yeah, we have this question from Darshan Gupte. Could autopilot vehicles be used as ambulances and improve healthcare?
Could autopilot vehicles be used as ambulances?
Ambulance.
So it's interesting. The most amount of crashes that Tesla has had with emergency vehicles, because it does not know how to deal with emergencies. Interestingly, that somebody mentioned, ambulances. But I mean, again, these are scenarios. These can be planned, and they can definitely be used. Right now, Autopilot 2, Autopilot 3, the latest Autopilot version, I think it still requires you to drive up to a highway before you can give control fully. I'm not sure about the exact the way this is playing out, but it is possible. Right now, at least for highway driving, these autopilots can work very nicely in an ambulance-based situation. But once we have fully self-driving cars, then I think it's a distinct possibility to definitely have such scenarios. Yeah.
I just wanted to also add to this, right? In the end, Anurag, the big problems come into place as long as you have a hybrid model. If you have manual driving and self-driving, that's when you have bigger issues. Like if everyone is autonomously driving, self-driving, then I mean to get there and achieve that is a longer way. But if you're there, then managing this will be easier. Because you mentioned it also, right? You don't have a system with a player you don't know, right? And then it becomes easier. But as long as you have that hybrid model, that's where the big challenges, in my opinion.
Absolutely, and we can. There have been talks about communities enforcing it in their environments first. Like imagine a campus, and we say everything has to be self-driving in that campus. So little pockets of it coming about before, it being played out. Maybe segments of road and so forth, that kind of thing.
Okay, there are some more questions, but Rishi, I just want to ask you, I mean, as Nagarro, you work with a lot of mobility clients. Some interesting examples of some projects you've done which has made a difference to your clients?
Absolutely. I think, thanks for asking that question, Sridhar. And I think, while you were hearing Anurag, it kind of gave everybody a sneak peek into how we solve our problems. How do we really deconstruct and demystify a complex problem and really solve it? We've been doing a lot of work with, both mainstream OEMs and new mobility entrants in the area of new business models in particular, and in the area of making the vehicle more intelligent. Now, since we're talking of cars, I'll give you an example. Imagine weather and cars. Weather information is very important for vehicles, right? You cannot be safe if you're driving in an adverse weather condition, and you need to take more. You need to be more guarded. Now, imagine if cars were able to understand what kind of a weather they're driving in. And if you could use machine vision to collect information of the scene that's there in front of you as a vehicle, and convert that visual cue into weather intelligence right there on the edge in the car. And imagine then that you're able to share this information with an interconnected network of vehicles, so that, and this is precise information of the exact lat long where this kind of a, let's say, a harsh weather condition has been generated. And then, and then therefore any other vehicle that's, venturing into that particular space is more cognizant about the environment in which they are driving. That's one kind of solution, that came to my mind since you were discussing cars. But again, talking of machine vision, imagine if you could use machine vision and AI to reconstruct accidents. If you're able to understand, what was the exact scenario that led to an accident. If the 8 cameras of a Tesla, they're able to, capture the events that were happening around a car that led to the accident, then you're able to, determine what kind of corrective measures need to be taken. Was it a road infrastructure problem? Was it a problem with the driving style of the driver, or was it let's say, a vehicle malfunction that led to it? So it's critical information that can help OEMs. It could help municipal corporations who need to work on, let's say, roads, or it could even help insurance companies in the claim settlement, if you will. So we're working on those kind of very niche and unique futuristic use cases in the context of connected intelligent vehicles. Besides that, I think there's a lot of work that we've been doing, and like I was initially saying, in helping our customers pivot to new business models, especially in the context of shared mobility. So we've been working with a lot of OEMs in introducing, conceptualizing, scaling, shared mobility platforms, because and what we've learned is that it's a big design problem. You need to really understand the operating behavior of your consumer, the context, the market. You need to build the right, robust digital solutions that can service, that can consistently and reliably offer those services, and then also scale those solutions, because a lot of our customers are also, let's say, they get stuck at point and it's difficult to scale a business model, right? So we're also helping them with scaling it successfully and profitably. So a lot of that work is happening. As Nagarro, I think, beyond just the business of creating these digital products and solutions, we have a more principled or approach towards mobility, and it's a topic that's very close to our heart. We have a not-for-profit group within Nagarro that's been working on using technology to detect black spots, or spots where accident probabilities are very high, and conduct road audits so that you could prevent accidents. In fact, we've been working with the government of Haryana in this program for several years, which is called Haryana Vision Zero. And that's basically aimed at finding these black spots where the probability of accidents is very high, and there's probably a road infrastructure issue or a signage issue, and fixing those and making mobility more sustainable that way. So yeah, there's a lot of interesting work that we've been doing in this space. Yeah.
This black spots reminded me, I think Intel is also trying to do something in Telangana. I think they tied up with some of the governments and all that, doing some fascinating things happening. No? So there are, I know we are out of time, 3 minutes past 7 India time. There are some questions from Samshvi Holi and Dharmesh Ranga, but I think you kind of answered most of them. Maybe some other time we can deal with some of those. Great discussion, fascinating subject. Like I said right at the beginning, no wonder there are so many questions. Delight to have all of you, Rishi from Munich, Sven from Stuttgart, and Anurag from Dehradun. Good, we could all be on a platform like this and talk about a subject like this. Thank you so much, Rishi, Sven, Anurag.
Thank you.
Thank you, Sujit.
Bye.
Thank you, Sujit. Thank you.
Thanks for having us.
Thank you, everyone.
Take care.
Bye-bye.
Bye.